Okay, are we recording?
Yes.
Okay, welcome to Thursday. Since I forgot to hit record, I'm gonna do this one again. We are talking about how division by fractions isn't actually strange. If you've only thought about it because your math teacher made it confusing, then you're going to think it's actually hard and confusing. But on the top, we have 6 pounds of brownie. Imagine each of these squares weighs a pound on some big, like sheet cake size thing in a professional
It's
kitchen.
a giant piece of.
And we're going to break it into 2-pound pieces, and we have 3 of them, right? 6 divided by 2 is 3, no big deal. We could also take that and break it into half-pound pieces. It's not like something that weighs half a pound is any freakier than something that weighs 2 pounds, it just doesn't make you as fat when you eat it. I can't break each of my pounds into 2 pieces, but you can imagine I did. I could even take a pencil and try drawing a line on it. I don't know if that will work, sort of.
Are we shattering those squares?
Yeah, we're shattering them into 2 pieces each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 divided by a half is 12. So you can do that without having been taught, quote, how to divide by fractions. And you won't actually get formal lessons about dividing by fractions until Math C. But for now, since we're talking about how division works, the point is just that division works exactly the same. It doesn't matter if you're dividing by a whole number or a fraction. You're just making piles of the right size. That's not how you were probably taught to think about division, though. Because if you were a normal American, your teachers only knew about division by dealing out cards. So if I wanted to do 6 divided by 2 equals 3, your teacher would say, I have 6 cards in my hand, and I'm going to deal them out to 3 people. So you get a card, you get a card, you get a card. I go around the circle of the table again. Everyone gets 2 cards.
Oh, we
I'm
have
sorry,
to
that was
do,
not-
Dylan knows part,
I know
we have
it's
to,
divided by.
we at the casino playing poker,
Yes.
and Dylan knows.
I did 6 divided by 3. I wanted 6 divided by 2.
Okay, cool.
2 people, so 6 to each of you, to each of you. There, now my 2 people each have 3 cards, right?
Yeah.
So dealing out cards is a good way to think about division, but only with whole numbers. If you ask me to deal out cards to 6 divided by a half, I get stuck. How do I give cards to half a person? Even if Gavin took out his samurai sword and chopped me in half, how do you give half a person a card? It's still giving one person a card, but they're bleeding, right? So, by the way, did you hear about the person who had to have his left side amputated?
No,
He's all right now.
oh, is it a joke?
Yeah, okay, so that was the point of this one. We're not here to learn about dividing by fractions, but when you get to them in Math C, don't be terrified, right? They're just
Cool.
division. But you have to think about making piles of the right size, like half a pound of brownie, not dealing out cards, because both of those work, but
Do
only
they
one
go
works.
best into chemistry or construction?
Does, which one?
This, right?
This,
Fractions?
chemistry doesn't like fractions, so this is another good thing to talk about. If you are in construction or baking, then you like fractions. And if you're in the chemistry or most of those sort of sciencey things, then you like decimals.
David, you're going over over the numbers on my tablet right now.
Well, that's okay. If you, when you ask your math teacher, do you want this answer as a fraction or decimal? Once we get to those, then hopefully your teacher will say either one works. I don't know if your future, Sean, involves carpentry or chemistry. So you kind of pick what you think will be the most practical to you.
What would be the one for business representative.
Your business?
Yes, for like business, like.
Ah, that's a great segue. We're gonna talk about that
Oh.
down here a little bit more.
Um,
I'll just show you, because I think you did you do this slide on Tuesday
Yes.
with Ann?
we did something like that.
So the business world is all about making things simple, so people will like your stuff and buy it, right? So the business world likes the kitchen fractions. They are the ones that are easy to think about.
Mhm.
You never want to sell something that has 7 servings in the bag. You want 6 servings or 3 servings, so you can eat a third of it or a sixth of it, right? You don't wanna make people do the hard math. So business likes kitchen fractions.
So that makes strong.
Or money. Money is
Makes
decimal.
Society if we can have that.
Okay, let's do another dealing out cards. This time I'll here so I can record it in the Jamboard and not just on the camera. So if I want to do 12 divided by 4, then what you've probably seen is that there's, again, pretend there's 4 people. Pardon my stick figure quality artwork.
It looks like we're playing Candyman.
It does kind of look like that, but not so violent. Okay, so I'm gonna take my 12 cards and deal them out to 4 people. So you get a card, you get a card, you get a card, you get a card. I keep going till I run out of cards. And then where do I look to find the answer?
With each person.
Yeah, the answer is how big the pile size is, right?
3.
So 12 divided by 4 equals 3. Answer is the pile size. Everyone with me so far?
Yep.
Yeah.
No.
So we could do the same thing with a big number. So I have my 4 people, and I just hit paste, yeah, oh, that makes me happy, okay. So there's my 4 people. And I'm gonna deal out cards to them. I have, again, like I talked about a week ago, some sort of magic superpower where I can reach to the top of a deck of cards and pick up exactly 100 or 10 or 1. If I want to pick up 10 cards, I can just do that somehow. So I'm going to do that with the cards here on the screen, 972. So we need 900s. 1, 2, 3. And then we need that 3 times. You go down there for now. Okay, there's our 900. Everyone okay with that? And then 7, 70. So there's 30. There's 60. And 1 more will make 70. And 2. So 1, 2. Okay, so I have 972 cards. Imagine they're all in a giant stack. I'm not sure why I have that many cards in the stack. And we're gonna deal them out. Can I deal out 100 to everyone?
Yes.
Yes,
I mean, no,
yeah,
I mean, yes,
I have 900.
yes, it's confused.
That's a lot more than 4.
Drop you.
So if I write this, then, yeah, no. Go away. Okay, so if I write this, it would be 4 goes into, 972. So I can give everyone 100. Let's do that. You get 100 cards, you get 100 cards, you get 100 cards. And you get 100 cards. Can I go around the table again with hundreds?
Yes.
Yes. So you get 100 cards, you get 100 cards, you get 100 cards, and you get 100 cards. Okay, can I go around the table again with 100 cards?
Oh,
Person would get one, but no one else would get one, so I have to stop. So I've gone around with hundreds 2 times. What I actually did was give 200 cards to each person, but we don't write the zeros because that gets too crowded. How many cards did I now put on the table?
80,
800.
800.
800.
So I have put on the table 800. I'm not sure why we don't write the zeros. They make it much clearer about what's happening. But usually we leave them off. I guess people were lazy or something. Okay, I've done my hundreds. Now I'm gonna deal out cards 10 at a time. Can I give everyone 10?
Yes.
Yeah, we can do that once. 1, 2, 3, 4. Can we do it again?
No. No.
Not with these 10s, but we still have 100 up here.
You break that in the rest.
So let's take that 100 and break it up. So you go away. And instead we get 3, 6, 9, one more. Okay, now I can go around with 10 again. You get a second 10, you get a second 10, you get a second 10, you get a second 10. Can I go around with 10s again?
Yeah.
So everyone gets a third 10.
You should draw a magic wand.
Can I go around a fourth time with 10? So I've done 10s 4 times. Can I go around another time with 10s?
No.
No, so 4 was all we got. So how many 10s did I give to each person? I gave them 4. I really 40, but again, that 0 don't normally draw. So 40 cards for 4 people, there's 160 cards I just put on the table. So then we subtract, there's 12 left. Is that true? Do I have 12 left? Yeah. So can I deal out 1 card to each person? Not yet.
Yeah.
But I can cash out this 10 to get a bunch of 1s. So 2, 4, 6, 8, 10. Okay, now I can give everyone 1 card. That was once around the table. Can I give everyone another card?
Yes.
So 2 times around the table. Another card?
Yes.
Yes, 3 times around the table. So I've given everyone 3 cards, and this time it really is a 3, not a 30, not a 300. I gave 4 people 3 cards, that was 12 cards I put on the table, and we're out of cards to deal. Does that help everyone understand how long division works?
Yes.
Yeah.
Thought, actually. They'll be similar at least.
Yeah, it's thinking that you have to understand place value to understand long division, which is why we did so much time on place value at the start of the term, because this was coming. Okay, can we do the same thing in Moodle here? Sure, I could do this with, if I had 6 divided by 3. So here's my 1, 2, 4. Oh, okay, now 6. So there's my 6. Remember the piles of brownie? I could make 2 pounds of brownie here, 2 pounds of brownie here, and 2 pounds of brownie here to do 6 divided by 2 equals 3. We just did that before with yellow tokens. This one here is halves. So what I couldn't do with my yellow pieces without some sort of saw, now we can do on the Jamboard. We can say, here I have, again, 6 pounds of brownie.
You got the meat figure out and pat that up.
So we can cut them all in half-pound pieces. And how many half-pound pieces are there? If we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How could I do 6 divided by 6? If I have something that weighs 6 pounds. and I say, let's put it in a pile that weighs 6 pounds. How many piles do I get? Just one, right? So everything divided by itself is one. That's just saying, if I weigh 12 pounds, then I get a 12-pound pile of me, that's all of it, there's nothing left over, right? So that's not strange at all. How about dividing by 0? If I had 6 cards. Dividing by 0, you might have heard, is sort of like infinity. It's not actually, but you can think of it like that. So here's my 6 cards in my hand on the camera. Let's make a pile of 0 cards. Okay. Let's make another pile of 0 cards. Okay, I can keep doing this as long as I want. I never use up any of my cards. So when you think about how big a pile you're making, it helps you with fractions and 0 in ways that dealing out cards doesn't. So have both ideas of division in your mind. That you can deal out cards or whole numbers. That's what we're most used to, because that was what was taught to us as kids. But you can also make piles of a certain size, like with rounds. Okay, any questions so far about any of that? Now, if you haven't had to do much, you've just been listening to me, but I want to make sure. Okay. Da-da-da. Okay, if it's okay with you, I'm just gonna put names by each of these. Think about them a little bit. Now it's your turn. And then you're gonna tell us all why you got the answer you did. Is that okay?
Yes.
Okay, I'm just gonna go down in the order that people are in my Zoom screen, which might be different than what it looks like in your Zoom screen. So I have Betty. Whoops, that's big and green. Let's try this. More electrical. Betty. Nikki. Kim, you changed your name. Kim, no, Kim disappeared. Okay, Alicia is here. Let me mark you down as present, Alicia. That's not Kim. Oh, okay, Alicia. Welcome, Alicia. I don't know you yet.
I'm new here,
Welcome.
Welcome.
and to be honest, I have no idea how to do division at all.
Okay,
I'm not bad
let
at.
me put in chat for you in case you don't have it yet. A link to where we are, if that helps you. You don't have to join the whiteboard, but if you wanted to, now you don't have to go into the Moodle class and click the click the whiteboard link right here.
Okay,
You can just keep watching because it is all this tech stuff is overwhelming your first time, so up to you.
okay.
Um, just so you know, actually, as long as we're interrupting a little bit. There's office hours tomorrow at 1:30 and Saturday at 11. And both can be Zoom. For 1:30, I'm also here in person. The Saturday is only in Zoom. So if you want to get a little one-on-one help with the tech stuff, then that's a great time to meet with me. We could also schedule something else that works best for you.
Okay, thank you.
Welcome.
Are you gonna do it this Saturday on Zoom, David? Cause you were supposed to go out of town for your
Yeah, but
son's thing.
The airplane flight isn't till later, so since it's just a 2-day trip, I don't need all morning to pack.
Okay, cool.
It might just be half an hour. No,
Sounds good.
I think Dave is more fun as a tutor, honestly. So this is
that is a good point. Any math teacher is probably more fun one-on-one than in a group. Because in a group, I have to somewhat teach to all of your different learning styles. And that means only part of the time am I doing it the way you want it. But when you come to office hours, then I can learn how you like it and you can have that kind of thing all the time. So that's just the limitation of it.
Okay.
So this could be Jody
That's,
and Sean. Kevin. Can I give you a problem, Chloe? Okay. So if you are here with me in the room, then we have cards, we have squares, we have poker chips, whatever you want to use to demonstrate your division. If you are in Zoom, then you can just sort of describe things out loud, or draw a picture, or whatever you want, as well as you can use the whiteboard.
Yeah.
And but you can just kind of narrate what's happening. I'm picking up 36 things in my hand and then dealing them out and so on. And that will be enough. You don't have to do anything. You don't have to actually make it away. Just out loud is good. So I'm gonna turn off the recording for a moment and think about how you will explain your division. Okay. Here we go. Okay, Betty, 370 divided by 2.
189 is the answer.
Okay,
And like I learned on old fashioned, all my multiplication and division and pluses and minus. So I did the old fashioned. I put 378 in the box, divided by 2 outside, and I did it like that.
okay, so 378 is inside something.
Yeah,
You-
and 2, yeah.
How many times does 2 go into 3?
It was 1, and I put 2 minus 1, and then I download the 7,
Uh-huh.
and well,
8
Yeah.
you said for the 189.
yes.
Times 2 is 16.
Mhm.
As a 10. And then 18 times 2. Okay.
Yeah.
Now- Okay, Nikki, 8 divided by a quarter, that's a very different problem. Did you get a good answer for that?
I had to use my calculator for that one because I don't work very well with fractions, but the answer is 32.
Okay. Do you want me to?
I have 6,
picture?
I have 16.
Oh, my phone said 32.
Okay,
Yeah, 32 is right, so.
okay, 32.
We did this one before, on Tuesday, right, so let's back up. So 8 divided by a quarter, whoops, I'm grabbing the wrong box, this one. So I have 8 things. What do you want them to be, Nikki? Birthday cakes?
Sure.
Okay, I have to erase that. There we go. Okay, so I have 8 birthday cakes. Let me draw them. You make them little. I make them too little, you can't see the plus sign.
Oh, it's 1, 4.
Two,
Yeah, you're right, Nikki. It's 1, 4. I
8,
saw that it was one half.
Oh, okay.
Yeah, you're right.
So here's my 8 birthday cakes, right?
Okay.
Mhm.
And for some reason, everyone at my party gets an entire quarter of a cake.
Yes.
So how many people get a quarter of a cake? So we'd have to count and see. So 1, 2, 3, 4 people get quarters of a cake from that one, right?
Right.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's where we got 32.
Okay.
Does it help to see 8 things being cut into quarters?
It does. Seeing a
Yes.
Helps a lot.
If you've been taught a rule, the rule might be that you take the division fraction and flip it over and multiply. But you probably, if you learned that rule, never had anyone explain why it works.
Yeah,
See it working? Can you see the times 4 on each of these cakes? Each cake gives you another 4 things.
yeah,
Okay, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8. So that's why that flip and multiply rule works. But again, that's math C, we're not really doing that. Okay, Jody and Sean, you have half divided by 2. 4, so how did you do that?
You use the whole halves, like if you have a two whole ones, two whole. You break them up to halves, you get like 4.
Okay, so you did something different, which is okay. You did 2 wholes, break them up into pieces of size 1/2,
Yeah.
and that was 4 different pieces. Whoops, I wrote the wrong. I'm saying a half, but not writing.
Yeah,
Break them up into pieces of 1/2, and you got 4 pieces.
yes,
So yes, that's good.
amazing.
If I wanted to do that, I'm not sure I have a circle cut in half handy, but we have these things.
Yeah, you
So I can just copy those,
put it over here, yeah.
put it over there.
Yeah. There you go, makes sense.
So I have 2 things, and I cut them up into halves, and there's 4 halves there.
Yeah.
Okay, Gavin, 225 divided by 5.
45.
45, okay. How did you think about that?
And then I just did the calculator.
Well, that works too. Again, on the GED, you could use your calculator for almost everything.
I don't. You know. I'm gonna do. Things like.
So I mean, there's 2 ways to think about this again. You could say, I have 225 cards in my hands. And I have 5 people in the room, so I'm gonna deal it out until I'm done. How many cards does each person get? 45. Or I could say, I'm antisocial. I have no friends. Who cares about that? I am going to make piles of size 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many piles of size 5 will I make before I run out of my 225 cards? And the answer would be, I make 45 piles. So both would be good ways to think about it. Okay, Chloe, 1/2 divided by 1/4.
It's 2.
2, and how did you get that?
You flip the 4 and you put it over 1.
So
Time.
you were taught to do this as, when you see a division by a fraction, then you change that. And that second number becomes a multiply that's flipped. Okay,
And then you have 4 over 2, which is 2.
okay. So how does it work with actual things? Okay, well, I show you that. So I'll just get a new one. So here's a paper towel. Everyone with me so far? You can see my paper towel on my camera?
Yeah, yes.
So I want half of a paper towel. So this is my half that I'm shading. This other half of a paper towel. That's not mine. That's Gavin's half. I only get half a paper towel to start with. Are you with me so far? Okay.
Yes.
Me first. What I actually want is quarters of a paper towel. So I'm gonna take a different color. And take my whole and make it into quarters. Is everyone okay that we now have 1, 2, 3, 4 quarters? I wrote upside down on the screen. Right, 1, 2, 3, 4 quarters for my paper towel. Okay, here's your half back. How many quarters are on my half?
2.
2, right? Could rip this in half again. I have 2 quarters with my half a paper towel. So even something as complicated as 1/2 divided by 1/4 doesn't have to be scary. We're not gonna do more of that, because as I keep saying, that's math C, but my job today is just to make you think that division isn't some weird mystery.
How am I gonna use it in my,
How are you gonna use it in real life?
yeah,
That. You have whatever, a half-foot board. What your project requires is 1/4-foot boards. How many 1/4 do you get out of each half foot? Right? I'm taking a half thing. I want piles of size 1/4, how many do I get? That kind of thing.
I did answer 36 divided by 4.
Oh, did I skip over you?
Yeah, I actually did do the problem.
Okay, what is it?
It's 9.
9. Yay, thank you. I am sorry, I just somehow skipped over you, Alicia.
That's okay.
I did not mean to, I am rude. That's okay, I'm not at my best. Did you want me to do any explaining about it or modeling of it?
All I did was just count a whole bunch of 4s out until I got to 36, and then I
Yep.
counted how many 4s I had.
Great. Once we get to fractions, then that method of counting multiples, counting by 4s is gonna be an important thing. So I'm very glad Alicia mentioned that now. Okay, so. One last little bit of things. You don't have to know how to do any math to do division. So imagine there's 2 kindergarteners, Kira and Keisha, and they're best friends, and they always want to share everything equally, to be fair. So they have a pile of little blue candies. They don't know how to count very well, they're only kindergarteners, but they could still say, I get 1, you get 1. I get 1, you get 1. I get 1, you get 1. So they don't need to do any math to do division, they just have to make equal sized piles
I got a
or
question.
deal out cards. So that's one thing to realize. And then something that we're not gonna talk about, but you can think about, is you can also divide things that aren't numbers. Everything we've done today has been numbers divided by other numbers. But there's division in other places too. If you wanna find all the ways of sharing a square. Well, I could cut it down the middle, that's certainly one way. But I could also. Come here, there we go. I can draw this right, cut it diagonally, and that would share. Or maybe I can even take a square. And erase the diagonal. And come on, square, you there?
The square doesn't wanna listen.
No, the internet is being funny, come on. There it is, okay. Or I could take a square and, connection restored, that would explain it. Come back, internet, we love you. Okay, or maybe I can take a square and do some sort of yin yang thing. And cut it evenly, if I could draw better than I can. Right, so there's lots of ways to make 2 equal pieces. They don't always have to be nice straight lines, although those are the simplest. So what else could we do for a square? Just top and bottom halves, that would work. So you can think about for different shapes, how you could divide them up fairly. Different than numbers. Okay, it is almost 7. Everyone okay for a few minute break?
Yeah.
Sure. Okay,
Yes.
see you in like 5 minutes. If not, that's fine. So, but for those of us who are here after the break, let's work on this one. How many students were asked about their favorite color? There's this chart that says, here's my favorite color, and then going up is how many students did that. So how many students liked red? Well, if you look, make it bigger. Then 1, 2, 3, 4, 5, 6 students picked red. Maybe it even helps to put the number at the bottom. Red was 6. How many students picked blue as their favorite color?
$11.
11, because that's how tall the blue bar is. How about green?
5.
5, and yellow? I think it's 7, right? Yeah, 7. It's a little hard to see by the time you have to go that far.
Fine, it's always a.
Okay, so now we can go back to the main page. So how many students total were asked about their favorite color? How would we find that?
No. Oh, you broke it up.
What was the question?
So we're doing the first question here.
Okay,
Students were asked about their favorite color.
29,
29. How did you get that?
added the numbers below each
Okay,
color.
yeah, we're assuming that each student picked only one answer. You weren't allowed to say red and blue. And then you would get 29. How many picked blue? We already did that, 11.
11.
How many, what fraction of the students had red? It's 6 out of 29. How do we write that as a fraction?
29.
We really only have 2 choices for a fraction. Does the 6 go on top or the 29 go on top? The 6 goes on top. And how do you know that?
There's 29 as a denominator.
Well, that's what we call the bottom, but how do we know that 29 goes there?
Exactly.
This is total student.
Yeah, this is like the total or the whole amount. And this is the part or the piece, that kind of thing, right? When you have a fraction, the top is usually smaller, not always.
Yeah.
But it's like the part we're interested in. Part question is asking about. And then the bottom is how many there are total in all the different possibilities. Okay, if you're back from break now, welcome. We are starting fractions. There was one more to doodle about fractions that we did on Tuesday, or you did on Tuesday with Anne. And we're introduced to the vocabulary of the kitchen fractions, the ones that people like most. 1 and 1/2 and 1/3 and 1/4 and 1/6. Did you do this one?
Yes,
Yes.
yes.
So the secret to this one was to think that, like Alicia did, we need to count by 4s in order for 1/4 of something to be a whole number. So what are the counting by 4 numbers between 20 and 30? Well, 20 is a counting by 4 number, so is 24, so is 28, and then we get too big.
Yeah.
We also need to count by 3s if we want 1/3 of something to be a whole number.
Yeah.
So what are the counting by 3 numbers between 20 and 30? They're 21, 24, 27, and 30. The only number on both lists is 24. So there has to be 24 students in the room. If it's accounting by 4 number and accounting by 3 number, that's the only one on both lists. And once we know that,
Is that a meme or a meme?
is that a what?
A meme or a meme?
Neither, don't worry about that.
Okay.
Just, it's a multiple, we're counting by something.
Oh, yeah, so that.
So if it's a quarter of 24, that's 6 that are sitting on balls. A quarter of 24 is 6 on cushions. A third of 24 is 8 on chairs. And then I add that up, 6 and 6 is 12, 8 more is 20, so there must be 4 left on the couches. So that was how to do that if Ann didn't explain it very well.
Okay.
We had to first get our counting by 4 numbers. Second, we get our counting by 3 numbers. And then see where they overlap. Because whatever it was, had to be a whole number that doesn't need to be rounded. We took a quarter of it or a third of it.
Okay.
But I don't want to spend too much time. That was Tuesday.
Okay, thank
Did you throw things and keep track? Someone got 4 out of 6. So again, the top is the part or the portion or whatever the piece. And the bottom is a total or the whole, whatever makes sense. And then that one we did. Great. Okay, so back to our thing. So remember the kitchen fractions from last time. It's okay that in math B, we only care about these. We will see a few fractions whose top number, whose numerator is different than 1, but not very many. And the ancient Egyptians used only fractions that have 1s on top for thousands of years. So it's not like we're in a rush to get to their fractions that you'll see in math C. What happens if the bottom is also 1? If I have 1 on top and also 1 on bottom, what is that?
One.
Yeah, that's just a different way to write 1 whole. We talked about that earlier. Something weighs a pound. And we make piles of a pound. That's all of it. It's not exciting. So there's some interesting things to think about. If you ask a mathematician, is this 1 number? He will say, yes, that's a number. If you ask a mathematician, is that a number? They will say, sure. If you ask them, is this a number? They will say, no, that's an expression. You have 4 and 8, some arithmetic. Okay, if I have 2 divided by 4, is that 1 number or 2? That looks like 2 numbers, right? 2 divided by 4. If I write it as a fraction, 2 out of 4 pieces, now suddenly people say, ah, that's 1 number. Okay, that's the same as 1/2. 2/4 is the same as 1/2. I could show you that with the circles up above. So there we go, 2/4 is the same as 1/2. But because 1/2 is something we can find on a ruler or a measuring tape, we want to say it's 1 number. But it's really kind of still 2 numbers. So just like we had something that was ambiguous earlier when we were talking about subtraction, do you remember there was, okay, stop scrolling. There we go. There was a counting past something, where was that? Here, this one. Oh, that's pigs, where was it? Here, this one. 7 plus something was 16. He started at 7. Went 1, 2, 3, 4, 5, 6, 7, 8, 9, and got to 16. That was sort of adding, because we were counting more than 7. But it was also kind of subtracting. 16 minus 7 is 9. So moving beyond how much more is kind of adding and kind of subtracting at the same time. So now we have a similar thing. Are fractions one number or two? No, it's kind of like they're one number and it's kind of like they're two numbers. So don't get too fixed on it. Keep your mind flexible.
If I ever have like, I'm studying some martial arts and math. You get language arts and martial arts.
Okay. Let's see. We can use pictures on a number line to compare things. Are we ready to do that?
Yes.
So if I want to shade in 1/2 with a highlighter. Okay, bad highlighting, oh well. Or if I want to shade in 1/3. Here's a third going up and down. Which was bigger, 1/2 or 1/3?
1/2.
The 1/2, it had 3 of the squares. The 1/3 only had 2 of them. Okay. If I want to write that on a number line, which number line is halves? If this is 0, this is 1. Yeah, here's the 1/2. So that's the one that we just did in yellow. Which one is a third?
Green.
0, 1.
That's the
Second line.
Yeah. 1/3, 2/3, and then 3/3 will be 1.
Yeah.
So 1/3 here is less than a half, okay? It's smaller than the half is. You can see it on a number line, you can see it on the squares. Okay, next one, let's compare 1/3 and 1/6. So 1/3 is still here. And that was here. And we wanted to label it as 0, 1/3, 2/3, then 3/3 is 1. What's a 6?
Box. One small box.
One small box, is that right?
yeah.
Bones and box.
One box, okay, whoops.
There you go.
Which number line is 6?
Think on the bottom board.
See, 0, is that right? 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 is 1. Yes, so 1/6 is only that much. It's less than the whole.
Yeah, 1/3 is big.
Everyone okay with that?
Yeah.
When I say that the GED has some questions where you're not allowed to use calculators, this might be the kind of thing it asks, which is bigger, a half or a third? Okay, we're not going to do equivalent fractions. This is just for some of you who are smart Alex and have looked at equivalent fractions before to understand things. We're not gonna probably do a whole lot of that. Okay, here's a trickier problem. We're going to start a race here at the starting line, right? Go this way around the track. The blue flag is half of the left. So let me pull everyone towards me. Can someone move the blue flag to be about halfway around?
Halfway?
Halfway around, yeah, and I'm gonna lock that so it's not moving. Okay, so we start here, we go about halfway around. And we get to the blue. I think if we're starting kind of in this diagonal corner, maybe halfway is actually more like there.
Okay,
Does that make sense?
yes.
Okay, kind of. That's halfway and then that's the other half.
Yeah,
Okay, the green flag is a third. That's even harder. So kind of imagine a peace symbol. Where is about a third of the way around?
The very bottom.
About there, yeah. So again, a peace symbol kind of thing. Would be thirds. The yellow flag is a quarter.
On the sides. Between the blue and the.
If I drew quarters. Then I certainly could say that the quarters change here. But that's not the first time you go a quarter, that's the second time you go a quarter, starting here, right? So I start racing 1 quarter, 2 quarters. So we want the yellow flag at the first quarter of the line.
Get to where you can.
You want me to pull you towards me?
Yeah.
Oh, the flag is very transparent.
Yeah,
Painting.
it's not my
Yeah.
fault, it's them, there's.
No, it's my fault, they made things too transparent.
Yeah.
So again, if we have the 4 quarters, first time you get to a quarter would be kind of right in the bottom.
Maybe I should put the red flag.
In the red flag 6, we have to chop things up into 6s, right? So the first 6 would be like right about there. So somebody decided to put the water stations at the flags, would that be a good plan?
What the heck?
Is it
No
not
water flies, water stations?
Yeah. Do you want the water stations spaced out that much?
Should be spaced out.
Yeah, you want water stations for a race spaced out more. Too many of them are in this first part.
See, it's spread out.
Yeah,
Like further up here.
yeah, we need to space them out. So there's a pattern though. That the bigger the number on the bottom of the fraction, the closer we are to the start of the race. Right, a third is here, a quarter is here, a sixth is here. So see that pattern too. Yeah. Okay, some good news. We're doing fractions because we're in math B and we have to do fractions. In real life, most people hate fractions and don't want to use them. So we have something better. We're not gonna jump to this now, but I just want you to know that something better is coming. Again, most of the reason we're doing these Jamboard activities is to kind of get our brains ready for what's coming. Okay, somebody can shade this. Let me pull you all towards me. Can you shade the first grid with a half? So pick a pen and a highlighter color and see if you can shade that well.
Okay, now I should be okay, I just splashed some water on my face to stay awake.
Okay. Okay.
Pretty good. It's hard with a mouse.
What did you say?
Yeah, that's pretty good. I need your full rest of
Okay, I'll help you then.
Sure. Why?
You got it. Okay, so here's the half that Gavin shaded.
So you got my piercing.
How many hundredths are in the half that Gavin shaded?
50.
50. So for 1/2, that's the same as 50 hundredths.
That's a half.
So the hundredths is just a whole one, right?
Each of these little boxes is a hundredth, because they're 10 by 10, yes. What if I was to shade a quarter? I can do that over here. How many boxes is my quarter covering?
25.
25. So the 1/4 is 25 hundredths. Everyone with me so far?
Yep.
Yeah,
The word hundredths is really awkward to say. It sounds too much like hundreds, and it takes a while to say. So what do people actually say? How much of this box is shaded red? They would say 50 what? No, they wouldn't say.
50 hundredths.
That's true, but that's not what most people would say. They could say a half, but if they said 50
1/3.
something, what would they say?
1/3 of it. 75%.
Percent, yes, they would say this is
50%.
50%.
Um,
Percent used to be two words, per meaning out of, and cent meaning 100, like 100 cents on the dollar, 50 out of 100. But because English is a terrible language, it got smashed together and now it's one word. And similarly, they wouldn't say this is 25 hundredths, I mean, it is, but it's much easier to say that this is 25%. So in real life, everyone is going to use percents instead of fractions. Because you can almost always do that. You have to round a little, like thirds don't become percents perfectly. But for most things in real life, it's good enough. And it's a lot easier to deal with percents than fractions.
So we're swapping out hundreds of percents.
Hundreds of percents are the same thing. just two names
The
of the
same,
thing.
two different mediums.
So if you don't like fractions, this is like your end of, light at the end of the tunnel. We're gonna keep doing fractions, but eventually we're gonna say, okay, we're done with fractions, we've paid our dues in math class. Let's talk about percents, because that's what really in real life will help you get it all.
Sounds good. I'm hearing that.
Okay,
So on the road.
I could start another to-do, but I wanna go back and look at little more, because I haven't done that with you now in a week, because Ann was saying.
Okay.
So,
Take that later. Take later.
We could say that for Tuesday, you could do that with
well, it's only 7:30, we might have some time, let's look. So, what would you do over the weekend if you're not coming with me to a gym meet? You're not. You could finish multiplication and division. Again, it says in the good textbook, put a 1.5 and 1.6. I'm gonna holler rudely and say, Alicia, can you hear me? This would be a great place to go at your pace, because you just joined us.
She got on.
Oh, let's get the screen.
David,
No, she disappeared. Wait, okay, yes.
I have a question. How do we, how can we mark when we finish like the multiplication or division like this?
It should just be. There's a mark as done thing and you go ta-da and click on it.
It's not allowing me.
It's not allowing you.
No.
Oh, I might have to change that setting. It's supposed to just do, but it's not letting me either. Okay, I'll go to text.
Yeah.
Say hello.
Oh, okay. Okay.
That's my problem, not yours. Good to let me, let me make a note on my attendance page. Mark as does not work.
You got the books waiting for us yet, or no?
well,
The books, which books?
There, yeah, there was
books or something that you were telling us when we started not to work on it yet, cause you didn't finish it yet.
Oh, okay, that's the.
Have you finished that yet or no?
No, I found where some other teacher had her answer keys, but she said some of the answers are wrong. So I can share those with you. But what I actually did was I started a new to-doodle where I would just write on them with my fancy thing.
Okay,
But I haven't had time to do that because I got sick.
okay.
So it's in progress.
Good.
Okay, but back to this. So anyone want me to show you how the textbook works again, or you've all seen that?
I know how that thing works, I don't need to see it again.
Okay, so there we go. It tells you where to go. Do some review. If you need more videos, our class video will be here. Because we talked about division and multiplication today. It's also going to be in the fraction one, because we talked about fractions. I don't think Ann recorded, did she on Tuesday? No, okay, so we missed out on that. And then you have all
I
these
took that
good
home, so I don't know.
YouTube things, if that's your vote. The worksheets you can do, but I don't have an answer key ready yet, so that's not terribly
Okay.
helpful. And then when you're all done with the textbook and any videos, say, I'm ready, let me prove that I got it, and then try these.
So basically, since Ann didn't do it and you were sick on Tuesday, so should we just not worry about doing Tuesday's homework over the weekend and just do
Well, the homework
Thursday?
isn't assigned day by day. Cause that would assume no one ever got sick or had job issues or things like that,
Okay.
right?
Okay,
So the homework is stay.
we'll just wait for you then.
The homework is stay.
We'll just take a break over the weekend from doing homework.
No,
We'll wait for
do
you to
homework,
wait.
but you stay caught up, since we just finished multiplication and division, now you can for sure be ready for that.
Right.
If you're not
Okay.
ready, it's because you haven't done the textbook practice, not because you're waiting on me. That makes sense? With fractions, we're not all the way done with fractions yet, right? We still have more fractions to do, fractions.
Yeah, more fractions, more fractions.
Two more fractions. So if you wanna do fractions, you can. You could look at the textbook, it tells you what sections. Right, you could look at some videos, the class recording from tonight will be up here, and you have lots of YouTube things.
Cool.
You could try the homework, but if the homework seems scary for fractions, then don't feel bad about reading. In
Okay.
class, we haven't finished fractions yet,
Okay.
that makes sense?
Yeah.
Okay.
David,
Yeah.
I also have another question. When I try to go and I want to do some of my open math, it says on no authorization session exists.
Which one? Let me click on it too.
Any of them since we start on the decimals.
So decimals, let me go to the decimals then, see. I might have not loaded right.
Yeah, not fixed yet.
Yeah, I
And
haven't
you go to my open math, and
tried decimals yet. That one looks okay, how about the next one? That one-
mine doesn't.
Oh, yeah, that's done.
That one is weird, let me make a note, it shouldn't say that.
Yeah, I have no access on any of those, on
Okay,
any of the classes. I've been watching the videos, it's really helping me, but I want to try to do some work on my open math, but I be not able to.
okay, if you don't mind, let me drink. I'm getting scratchy. If you don't mind, Betty, I'll just stop class a couple minutes early, and then you and me can look at things.
Yes,
Have to do is, as a teacher, go into where it says participants and see if there's anything funky in your settings. But I don't
okay,
do that during class, because it will put your L number on the board and stuff like that, that I don't wanna do,
okay,
privacy reasons.
okay,
Okay. Okay, any questions about homework or what you can do this weekend?
No, but I do wonder what's the menu gonna be like for next week for
We're not done yet.
Wait, for next week, the menu, are we gonna make pancakes or waffles for dinner next
Oh, I
week?
don't know, we can look at that, let me pause the recording, we don't have to record that. On hold. So use the shape tool, your turn to do something, so the shape tool here on the side,
You drag me through.
and yeah, drag you to me. And we're going to draw 4 rectangles. And here's the challenge, the smallest one should be a quarter of the biggest.
Okay, this is good because they're hard for me, I do not know how to draw rectangles.
Just don't draw it by hand, that's not gonna work.
Yeah, don't draw right now, honey.
So
You
use the
never gonna get it.
use the rectangle. Or just copy and paste On's rectangle, he has one, so we can just copy and paste it.
No,
Sure you can't, it's not letting go of it.
Go ahead.
Well, that looks like you're selected it on this.
Oh, I didn't, hold on, get out of it.
You might need to click again.
There you go, go ahead.
So try and make 4 rectangles that are the right size compared to.
Oh, you want me to make? Oh, okay.
Yeah, I was trying to get to make 4 rectangles, I'm not good at making rectangles.
Different size rectangles?
Yeah, you can just drag the corners to make them bigger or smaller. Just put down 4 rectangles and adjust them after you have them.
Oh, okay. Okay.
I'm like, where do you do this? I'm not good at making
And
rectangles.
then control V. And then paste, there's that one,
How do you do this, honey? I can't do it.
Control V, there you go.
Now do mine, I can't do it, I can't make rectangles.
Okay, so we have lots of rectangles, more than we need. So how do we make the smallest a quarter of the biggest?
Make it in 4 pieces.
Yeah, so we can say, let's shrink that
Cool.
and make 4 of it. 1, 2, 3, 4, right? And then we'll
Yeah,
this one and make it that big, whoops. We'll make this one, let's make this a different color and thickness so that I can move it nicer. Oh, no, and it's just the rectangle, there we go.
I think you're have to go home and rest that voice, David.
Yes, I will, okay, now I have the green one. So I make the green one as big as that, right?
Yeah.
Now I can move the green one off.
I
Get
mean,
rid of these. Okay, but now the smallest one is a quarter of the green.
okay.
How about something that's a third of this? How would we do that?
Maybe.
cut it in 3
One.
pieces.
Set it in 3 pieces, so I'm gonna take this one, it looks pretty close.
Yeah.
1, 2, 3. Okay, I need to make the green one a little taller. Whoops, but not, I shouldn't change the width of it.
Uh-oh.
Okay, so. 1, 2, 3. Okay, so now it is 4 of these wide, and 3 of the others down, right? Okay, so the green one is 4 times this going sideways, 1, 2, 3, 4. And 3 times this going up and down. Now I want another one that's half this big one.
Cut it in half.
I can just do 2 quarters though, right?
Yeah, pretty much.
So there's 2 quarters. And I'll make this one say. Blue. And make it as big as.
Pleasure, Derek.
Thanks, allergies.
There you go, 2 of the quarters.
Okay. Okay, so there we go. So the blue, whoops, I'm gonna move that one off. So this is a half of the big one. This is a quarter of the big one. And this is a third of the big one. Did it help to start with the biggest or the smallest rectangles?
The biggest.
No, we built the biggest out of.
I mean, the smallest.
Fourth is small, third is
So
medium.
the lesson for this one is a lot of GED problems are like this. Do you start with what's big? Or do you start with what's small?
You start with
And if you
what's
pick
small.
the wrong thing, then you don't get anywhere. So realize you picked the wrong thing and try the other one. If we started thinking about the biggest rectangle first, then it would be hard to say what's exactly a half of it.
So we're
But
trying
if we
to,
picked a small one, we can make 4 copies easy. So if one strategy doesn't work, don't keep hitting your head on the wall. Try it the other way.
maybe I'm not easy for it.
Not all, I do it over.
And. Okay, new thing, and then we'll stop and I'll help Betty with.
We're here.
So Chantel is making her friend Jasmine a beaded bracelet using their favorite colors, teal and purple. She uses 3 teal beads up at the top and then 2 purple beads. So we're imagining a bracelet that goes lump, 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 purple, purple, teal, 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 purple, purple, like that, right?
Your color eyes.
So if she needs 45 beads total to go around her friend's wrist,
Okay,
how many beads would be of each color? How would we find that out?
Take the 40 something. So we use 2005 right there. Yeah. So very.
Yes, Gavin said something great. Did you hear?
Fives.
This whole group is 5. So if you had 45,
9.
then that's 9 5s, right? So that means you'd have 9 times 3 for the teals. What's 9 times 3, by the way? 27, right? And you'd have 9 2s
18.
for the purples.
18.
That's 18. So this is another one where if you tried to think about 3s or 2s right away, you don't get any.
yeah, you just combine them.
You have to think about the 5 first and then.
And then you go from there.
About 3s or 2s.
Then you go from there. Yeah.
Yes. Okay, what fraction of the pattern with 5 is teal? 3 out of 5.
3 out of 5.
What fraction of the whole bracelet is teal?
3. 3 out of 2.
It's still true, 3/5 is teal.
Yeah,
It's also true that out of all 45, we know how many are teal. 27. So these are equivalent, but we're not gonna talk about that.
okay, got
Ah,
it.
oh, yeah, didn't even tell you,
Okay.
Ben.
My brain is screaming.
This is where we'll start next week on Tuesday. So if you want to show off, you can look at this and solve it by yourself before Tuesday.
Okay,
Or ask me about it in office hours Friday or Saturday,
okay.
and then you'll know and go, haha, I can show you the answer, but otherwise we'll start here on Tuesday.
Okay, sounds good.
Yeah, his brain looks like it's about to explode.
Oh, it's trying to.
Okay, any last questions? I'll turn off the recording.
Well,
No, we're good. What about Eddie?